I want to take a look at an example of graphing an ellipse here. So let's come up with an ellipse equation. So I will do a shifted x squared over some number plus a shifted y squared equals 1. And let's make this x plus 2 squared over 9, and let's make this y minus 4 squared. Now, this doesn't look quite like an ellipse. We have an x squared and a y squared. We have the plus. We have the x squared part over a number, but the y squared part is not over a number. But that can happen. If there's not a fraction there, you could always make it one by putting it over 1, and that's going to be helpful to us. So let's move this out of the way. This is the equation that we're going to graph here and find some other parts of it. Well, the first thing I'd like to know is where to do all my measurements from for this ellipse. And for that I need the center. And the center comes from my shifted x's and y's. My x part, x plus 2, is shifted left 2. Or in other words, the x coordinate is going to be negative 2 because that's what I'd plug in for x to make this x part 0. So my center, the x coordinate, is negative 2. My y coordinate is shifted up 4, or I could think plug positive 4 in for y to make the y part 0. So my center's y coordinate is 4. Now I can start drawing some things on the graph here. So I'll plot my center at negative 2, 4. That's here. So I'll do all my measurements for this ellipse that way. So what I need to know now is how far right and left to go, how far up and down to go, and then we'll locate the foci. So the first thing is, with x, I've got 9 on the bottom. Everything in this equation is squared. These numbers give me my distances to measure. 9 is going to tell me how far to measure in the x direction, 1 is going to tell me how far to measure in the y direction. These numbers are squared though, so my distance here is actually the square root of 9, or 3. My distance here is the square root of 1, or 1. So I need to go 3 units in the x direction, meaning 3 units to the right, 1, 2, 3, and there's a point, and 3 units to the left, 1, 2, 3. And there are some points on the graph. Now, I could figure out what these points are simply by marking the x-axis and measuring. These are called vertices. The vertices are 1, 4, that's this one here, and negative 1, 2, 3, 4, 5, negative 5, 4. And that makes sense. I went 3 to the left of negative 2, so I'm at negative 5. Now I need to go 1 unit in the y direction from my center. So I go 1 unit up and 1 unit down from my center. So that's here and here. These points are on the shorter axis, the minor axis. So these are not vertices. These are just points to help us graph. Some books consider those to be vertices as well and say that an ellipse has 4 vertices. So here's the graph. Now we've graphed it, but let's go ahead and figure out some more information, such as where the foci are. For the foci, if I were to redraw my ellipse, it would look something like this. The foci would be on the big axis, the major axis, inside the curve, so they're like here and here. And what we'd do is we'd call the distance from the center to one of the focus f, or something like that. Name it something. We're trying to determine that distance because if I know that distance, I will know where my point is on the graph. So what I do is I draw a right triangle using this f distance, this vertical distance, which from the center to the top is 1 in this case, and then I just make my hypotenuse as such, and that's always the other distance, which was 3. So the bigger distance is the hypotenuse, the shorter distance is a leg, and f is a leg. Now I can use the Pythagorean theorem to find f. So f squared, this leg squared, plus this leg squared, equals the hypotenuse squared. Solve for f. F squared is going to be 9 minus 1, which is 8. So f is the square root of 8. So that means the distance from here to my focus is the square root of 8, and that's, that's 2 point something, 2 point something close to 8. Or sorry, close to 3. So I go 1, 2, and a little bit more. One focus is going to be there. And I go 1, 2, and a little bit more. The other focus is going to be there. Now I have to know what those ordered pairs are. So think about this. The x-coordinate, well, the y-coordinate of both of these is 4, so that's easy. The x-coordinate's where it's difficult. So I measure from my center. My center's at -2. To get to this x-coordinate, I have to go to the right square root of 8 units, right? That's how you go. That's how you measure to get there. So that x-coordinate would be -2, my starting point, plus the square root of 8 because I'm moving to the right. Similarly, this one, if I start from the center at -2, I have to go left the square root of 8 units. So I'd have to subtract the square root of 8 from -2. So my foci are at -2 plus the square root of 8, 4, and -2 minus the square root of 8, 4. Finally, if we wanted, we could name the major axis length. Well, the major axis is 6 units long, 3 on each side. The minor axis length is up and down, 1 unit up, 1 unit down, so that's 2 units. And now we've described everything about this ellipse, we've graphed it, and we're done.